So this is going to be the last problem. So we're still going to use the divergence theorem over this vector field to find the flux of this closed surface. So we have a paraboloid and we have a plane z equals 0. So it'll be a lot easier, but the integration can be a little bit tricky too. So that's why I'm giving this problem. So let's first start off with the surface itself. So you can see that our surface is just a basic paraboloid going up 6 units and then coming down. And then you got this, obviously, z equals 0 thing going in there. And you got this force field. Okay, so this could be probably like rain. So this can be like an umbrella. Well, not really an umbrella, a little softer umbrella. That's more like a membrane. This can also be a membrane, like a cell, and you have water through osmosis. It can be many different things. So we're trying to figure out the flux. So what would we do in this case? Well, luckily for us, all we got to do is to use the divergence theorem because it tells us that it's a closed surface. Okay, so we don't need to parameterize anything. All we really got to do is find the divergence of f. So divergence of f for vector field is going to be each of the partial derivatives. Partial p over partial x, partial q over partial y, partial r over partial z. So let's take all of our partial derivatives. So what that's going to give me is going to give me 2z for partial q over partial y. That's going to give me negative, let me get rid of that, negative 8xy. And then the other guy is going to give me a 2 minus 2z. So 2z's cancel out, and I'm left with just negative xy plus 2. So that's kind of what I'm left with. Let me write it a little bit better. 2 minus 8 minus xy. That way the minus is on the other side. Okay, so now all we want to do is find this flux. And we are using the divergence theorem, so the triple integral over the region E of 2 minus 8xy dv. Okay, so if we look at a paraboloid, you can see that to set up this triple integral, it'll be pretty straightforward. We first going to start off by doing an upper minus lower problem. So this is going to give me, so oh, sorry, I got lost. Okay, so my z is going to be between the bottom part, which is 0, and the paraboloid, which is 6 minus 2x squared minus 2y squared. So converting to polar would be actually really nice. So it'll be from 0 to 6 minus 2r squared. So this is going to be from 0 to 6 minus 2r squared. Okay, so because we converted to polar, that means we're going to have an r d theta. And we're going to have a dz for our third component. Okay. Now, because we're converting to polar, now that means that my integrand is going to be a little different. So we're going to have this 2 minus 8. So now x is going to be r cosine theta, y is going to be r sine theta, which is going to be give me r squared cosine theta sine theta. So you're going to have all of that. Now my radius in this case is going to be the projection that you get from this paraboloid, which is going to be this guy. So that happens when z is equal to 0. So I'm going to plug in z equals 0 in there. And you can see that the region that I get is a circle of radius 3, or square root of 3. So it's going to be from 0 to square root of 3. And then my whole circle is going to go all the way around, so from 0 to 2 pi, since we want the whole paraboloid. So this guy is just going to give me the integral from 0 to 2 pi, integral from 0 to square root of 3, integral from 0 to 6 minus 2r squared of 2r minus 8r cubed cosine theta sine theta dz dr d theta. Okay, so this integral is going to be a little gnarly. So let's take the antiderivative. So the antiderivative of this guy is just going to be the triple integral from 0 to 2 pi, 0 to square root of 3. So you're going to get 2rz minus 8z r cubed cosine theta, sine theta, dr d theta, and this is from 0 to 6 minus 2r squared. So you're going to have the integral from 0 to 2 pi, the integral from 0 to square root of 3, and then you're going to plug all that guy in there. So 6 minus 2r squared minus 8, 6 minus 2r squared, r cubed, cosine theta, sine theta, dr d theta. So not a pretty integral. Okay, you got to do a little bit of algebra. So I'm going to FOIL a couple of things out. And what I'm going to get is the integral from 0 to 2 pi, integral from 0 to square root of 3. So you're going to get this, this guy. You're going to get negative 12r minus 4r cubed. I'm going to distribute just the 8 and the r cubed. So I'm going to leave the negative on the outside. And in the inside, I'm going to FOIL out whatever that was, which is going to be that negative, what is this, 48? Oh, no, positive 48 r cubed. Then a negative 16 r to the 5th. And then leave the cosines on the outside. So there's a reason why I'm doing that. That way it's a little bit nicer to see. dr d theta. So I don't have to worry about writing cosine and sine over and over and over again if I distribute it. Okay, and now all I'm going to do is now I'm going to have to take the antiderivative with respect to r. Okay, so this guy is just going to give me the integral from 0 to 2 pi. This guy's going to give me a, wait a minute, this should be a positive. Okay, positive. Did I mess up anything else up? Okay, so now this is going to be 6r squared minus r to the 4th minus, and then the antiderivative of that guy is going to be 12r to the 4th minus 8/3 r to the 6th. And then the cosine and the sine stay the same. And from 0 to square root of 3 d theta. Okay, so now putting this all together, when I plug in the square root of 3, I'm going to just tell you what we end up getting. So we're going to get 0 to 2 pi. You get 9 minus 36 cosine theta, sine theta. So it does simplify a little nicey. Okay, and now what we're going to do is just take the antiderivative now. So 9 theta minus 3. Well, here, what are we going to do? We're going to have to use u sub. So the 36 stays there. And the u sub, let u be sine. So the u is going to be cosine. So you're going to have sine squared theta over 2. Then from 0 to 2 pi. Notice that the 2 pi is only going to influence the 9 theta. So that's going to give me 18 pi. The zeros are going to cancel everything out, including that sign, because 0 and 2 pi will just give me 0. So 18 pi will be my my flux using the divergence theorem. Okay, so notice that even though the integration is it's a little messy in this case, but it's still doable. Okay, it's still doable because at this point you should be very comfortable with the integration, and because you've seen a lot of it already, and all you really need to do is apply the Calc 3 methods that we've learned in class, and then everything else would just be integration that we've already learned. You should be very careful with the arithmetic, with the minuses and the pluses, because as you can tell, it's really easy to mess this thing up. Because one little error, one little minus, one little plus, just like me, could really mess up the whole thing.